Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded Module 1 to Module 3 in my channel. If you have missed out, please do check out from Module 1 to Module 3 in my channel. In time response analysis, I have already done some of the topics. Today, I will do problems on it. Under the time response analysis, I have already done all the topics which are under the first chapter. So based on these topics, let us see the problems in this video. The closed loop transfer functions of certain second order unity feedback control systems are given below. Determine the type of damping in the system. We need to determine the type of damping, either underdamped, overdamped or critically damped. As in the previous video, what I have mentioned is the different conditions in the second order system. Okay, there based on the damping, we need to decide based on the damping ratio, the Xi value. We will decide whether it is underdamped, overdamped or the critical damp. We will see how. If you see here, you know that if you see C of S by R of S, first question, 8 by S square plus 3S plus 8. You know that comparing the given transfer equation with the standard form of standard function of second order system, as I told in the second order system, I have mentioned the there is a one equation which I told which is very important. You need to remember, that is omega n square by S square plus 2 xi omega n S plus omega n square. If you compare this with this, it looks similar, right? So what we can do, you can compare that with this. And if you see here omega n square is what? 8. So omega n will become what? Root 8. So it is 2.82. And 2 xi omega n is what? Is 3 here. So xi is equals to 3 by 2 omega n. 2 omega n, you know the value. If you substitute that, you will get what? Xi is equals to 0.53, which is what? Xi is less than 1, right? 0.53 is less than 1, no. So it is called underdamped system. Okay, like this you need to based on the topic of second order system, the condition Xi less than 1, Xi greater than 1 or Xi is between 0 and 1, we need to decide whether it is underdamped or the overdamped. If you missed out that video, please do check out. It is the part 2 video which is second order system, time response of second order systems. There I have mentioned all the conditions in a kind of a point wise, so that it will be easy for you to understand. So here based on that, here if you see Xi less than 1 is what? It is a underdamped system. We'll go to the next question. Next question, again if you compare this with this, if you see here, omega n is what? Omega n is 2 here. So 2. Omega n square is 2. So omega n will become root 2. Then 2 omega n is what? 4s. 4s. So 4, if you substitute here, you know the values omega n. If you substitute them, you get 1.41, which is greater than xi 1. Xi, which is more than 1. Xi is more than 1. So it is called overdamped. If it is less than 1, it is called underdamped. If it is more than 1, it is called overdamped. We'll see for the third question. Here one more important point I need to tell here is, while comparing, don't compare omega n square with this equation, with this number. Why? Because maybe if it is 2 into 1, then omega n will become 1. If you see here omega n square is 1. This 2 is just a multiply of the equation maybe. Maybe it is like this, 2 into omega n square, like that it is. Okay. So 2 is just a multiplication maybe. Why? Because so you compare this equation with this. So if you see omega n square is what? 1. So omega n will become 1. So 2 xi omega n is what? 2. So xi is equal to 2 by 2 omega n. 2 by 2 again will get 1, which is equals to 1. If the value, xi value is 1, then what it is called? It is critically damped system. Next, fourth question. If you see again here, that it is the form of s square plus 4. Okay, there is no 2 xi omega n, whereas omega n square is 4, omega n will become 2. To 2 xi omega n there is not there, so 0, xi is 0. When xi is 0 means it is less than 1, it is undamped system. When xi is 0, it is undamped system. Maybe it can be undamped system, underdamped, critically damped. Okay, these all are different damping of the system. Okay, like that you need to understand based on the second order system. You need to compare to the equation whenever you see in this way, like xi s square, something called as 2 xi omega n. This whole thing is 2 xi omega n plus omega n square. If it is in this form, you should directly compare with the second order system equation and find whether it is the underdamped, overdamped, undamped, critically damped based on the equation comparing. Now this is the different type of question. The first order system and its response to a unit step input are shown in figure. See, this is the first order system. K by S plus A is the block with R of t and C of t. It is the transfer function, and its response is also shown. Determine the system parameters A and K. We want to find A and K. How to find? The system transfer function is already given as what? C of S by R of S, that is K by S plus A, which is a Laplace transform of C of S by R of S. But because while you are taking output by input, you will consider the Laplace transform of output by input in transfer function. For unit step input, as it is given, it is unit step input, R of S will become what? 1 by S. Unit step is 1 by S. The Laplace transform of unit step is 1 by S. So, if you substitute R of S as 1 by S into K by S plus A, the same way we have done for the second order system, now substituting the input R of S, same way you need to substitute. Then the steady state value of the output is, the steady state value how we can find? Limit t tends to infinity, C of t is equals to limit t tends to infinity, Laplace inverse of this equation. But directly you can't find the Laplace transform. What we can do? Partial fractions you can do, like 1 by S minus 1 by S plus A. K by A if you take out, okay, K by A if you take out, then 1 by S plus 1 by S minus 1 by S plus A. Again if you take LCM and do no, you get the same equation back. Okay, same like this you need to partial fraction it. Then K by A limit t tends to infinity. The Laplace inverse of 1 by S is what? 1, and 1 by S plus A is what? E power minus at. Right. So that is equals to, as if you substitute t is equals to infinity, this value becomes 0. 1 minus 0 will become 1. So K by A is the steady state value of the output. Okay. From figure 4.15b, where this response if you see, the for C of infinity is equals to 1. It is given as, when if it is C of infinity, the value is becoming 1. As the value is becoming infinity, the value C of t is becoming, C of infinity is becoming 1. So, if you take C of infinity is equals to 1, therefore, K by A will be equals to 1. So, K equals to A you can write. Or the initial slope of the output, limit t tends to 0, initial slope t tends to 0, d by dt of C of t if you do, then what you will get? 1 by 0.1. Output by input, that is 1 by 0.1 you will get as 10 as the answer. So Laplace transform of d by dt of C of t is equals to S into C of S is equals to S into K by S into S plus A, that is equals to K by S plus A. Okay, slope of the output is what? D by dt of C of A, Laplace inverse of K by S plus A. If you do Laplace inverse of is this what? K into e power minus at. So the initial slope is equals to limit t tends to 0, d by dt of C of t, that is equals to K. Why? Because when you substitute t tends to 0, then it will become K. So K is equals to what? 10. Okay, K is equals to what? 10. So a is equals to k is equals to 10. Why? Because limit t tends to 0, d by dt of c of t, if you do initial slope, output by input. Slope means what? Output by input. So 1 by 0.1. So it is 10. As this is and this is same left hand side, so k will be equals to 10. As k equals to a equals to, as k is equals to a, then you can write a equals to k is equals to 10. So the value of a and k are what? 10. Like this you need to solve. Same the derivation what we have done for the second order system, no? In the same way we are adding the input, we are substituting the input, we are finding the steady state value, so that you can find the a and k values. There is a chance of asking why? Because this is related to second order system, so please please do make it note, so that if they may ask the question, so please be ready. Obtain the response of a unit feedback system whose open loop transfer function is for a unit step input. Okay. So if you see here, g of s is given as 3 by s into s plus 4, and it is given unity feedback system whose open loop transfer function is also given. Okay. Then and if you see, there is a h of s as 1. So c of s by s of r of s will be what? D of s by 1 plus, why? Because it is minus, you will take plus 1 plus g of s into h of s is 1, so no need to take. So if you substitute this g of s, you will get as this. For a unit step input, what? R of t will become 1. Therefore R of s is what? 1 by s, right? So R of s is 1 by s means you can substitute in the place of R of s. Then you will get 3 by s into s plus 1 into s plus 3. In terms of partial fractions, you can convert in this way. When you take LCM and again and all, you will get the same equation back. Taking the inverse Laplace transform, same you can take same the previous question how we have done. We need to take Laplace transform. Inverse Laplace transform, c of t is equals to what? 1 by s Laplace inverse is what? 1, and 3 by 2 is multiplication, and 1 by s plus a is what? E power minus at. So as a is 1 here, you will take e power minus t plus 1 by 2 into e power minus 3t. Why? Because Laplace inverse of s plus 1 by s plus a is what? E power minus 8t. So a in place of a here it is 1, so it is minus t. In place of a it is 3, so it is minus 3t. Understood? Then a positional control system with velocity feedback is shown in figure. Okay. What is the response of this system for a unit step input? Input is a unit step input. They are asking what is the response. We need to find the response. Response is nothing but inverse Laplace transform we need to find. So the closed loop transfer function, if you see, this is g of s and this is h of s. If you put g of s by 1 plus g of s into h of s, okay, this is g of s, no? This is g of s and this is h of s. So g of s is this, g of s, and this is h of s. So if you substitute, you will get done by s square plus 4s plus 10. For a unit step input, r of t will become 1. So r of s is 1 by s. You can substitute r of s here. So c of s will become 1 by s into 10 by s square plus 4s plus 10. If you see here, you can do partial differentiation here. How? A by s plus bs plus c by s square plus 4s plus 10. You can write based this is based on the mathematics. So a by s, if it is the equation is in this way, then you can write a by s plus bs plus c by s square plus 4s plus 10. Then 1 by s minus 1 by s minus s plus 4 by s square plus 4s plus 10 will come as the value. If you calculate this, then you will get a, b and c values. Okay, b here b value is 1, a value b value is 1, and a value is 1, and c value is 4. If you calculate this based on the partial fraction, you will get this. Okay, then 1 by, you can search how to do partial fraction and do this. Okay, 1 by s minus s plus 4 by s square plus 4s plus 10, that is equals to 1 by s minus s plus 2 by s plus 2 whole square plus root 6 whole square minus 2 by 6 root 6 by s plus 2 whole square plus root 6 whole square. Okay, this equation can be written in this way. Okay, then taking the inverse Laplace transform, what you will get? This is 1. For this, it is, as this is s, this is s square and this is a square. It will be cos e power minus at minus 2t, as a is to cos root 6t. Cos root 6t. So, as this is in the form of a by s square plus a square, this can be written in terms of sine root 6t. Okay, in this way you need to know maths also in this in little bit what you have studied in PUC. Why? Because this is a partial fraction. What it is used? Partial differentiation. When if you want this, how we should do? If you want, I'll explain here once so that you'll understand. See, a by s plus bs plus c by s square. These type of sums, this kind in one of the video I've already done, not in this module but the previous module. If you have watched that, you will you will know it. Actually, 10 by s into s square plus 4s plus 10. Okay, I'm telling how this has come. Just a overview I'll tell. Here the if you see this denominator and this denominator same, you can cancel. But when you can cancel, when you can cancel is you need to take LCM here first. You need to take a into s square plus 4as plus 10s and here bs square plus cs. Then you can cancel this. After taking LCM, you will get one equation. No, that you should equate to 10. Now then what we should do? All the s square terms, all the s terms, all the no s terms which are not s, that terms need to be separated and if for example here if you see c is equals to what is c equals to is, wait, I'll tell. If you see here, I'll write that equation if you want. See, a into s square plus 4as plus 10a. Okay, 10a plus bs square. I'm taking LCM plus cs. If you see here, there is only one constant term. Then if you see 10a, here 10 4as plus 10a plus bs square plus cs. 10a, only one is there. So 10a equals to 10 you can do here. Why? Because it is a constant term. 10a equals to 10 is what? A equals to 1. If you see, you got a equals to 1 here. Understood? In the same way, what you should compare? As square will be equals to what? Actually, you got anyway you got a value, so no need to compare that. But what you should do? As square plus bs square equals to 0. If you do as square plus bs square equals to 0, if you do, why? Because there is no value here, only 10 is the value you go have. So bs square equals to 0. A value got 1 already. So so what you will get? B s square plus s square, right? bs square plus s square. So what you will get? B plus 1 into s square, or if you keep like that only, what you will get? S square plus bs square equals to 0. Let it be like that. Then one more, what you have? S terms you have 4as plus cs. Okay, 4as plus cs equals to what? 0. So for a terms is 0. So 4s plus cs equals to 0. So cs will be equals to what? Minus 4s. So c will become what? 4 minus 4. Understanding? Like that. Here b will become what? Minus 1. So s plus 4 will be the value. Like that you need to calculate. I just shown. You should just take the LCM, whatever the equation. I will show which equation you should take LCM once again. If you see here, this this equation is there, no? You need to take LCM, then equate, then this and this get cancelled because the denominators will be same. Then you need to equate this with this. What are the terms? What I've shown here, no? Like that you need to do. Then you will get the values. From that you can do this, and you can take inverse Laplace transform, which is the response of the system for a unit step input. So by this, the first chapter of this module 4 is done. Time response analysis is done. Next you have stability analysis. That in that topic, what are the contents? I'll do separate video next in that topics in the next video. So for now, I'm stopping the video. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.